Hello children, welcome back to our class. Last classes we have seen that first chapter, matter around us. Today we will move to a fresh topic, that is matter around us pure? And then in that first chapter we have seen the classification of matter based on the physical properties as solids, liquids and gases. And in this chapter we will see the classification of matter based on the chemical properties. How do the matter particles are classified based on their chemical properties? On moving to our topic, classification. Okay. Classification based on chemical properties. Classification of matter based on chemical properties. Now we can see how do this matter is classified into different classes. Okay, so based on the chemical property, matter is initially classified into two classes. First one, pure substances and the second one is mixtures. Based on the chemical properties, matter is classified into two classes, pure substances and mixtures. Okay, and then this pure substances are classified into again two as elements and compounds. Elements and compounds. And this elements, we will classify the elements into three: metals, non-metals and metalloids. Elements are classified into metals, non-metals and metalloids. Okay, and this half, that about that classification of pure substances and what are pure substances, everything we will see in detail in the end of this chapter. Okay, at the end of this second chapter we will see this part in detail. Okay, and in the first part we will see that classification of matter into mixtures and again further classification of mixtures. Okay, so we can say that I will tell you the definition of pure substances. Pure substances means substances made up of only one type of materials. Okay, pure substances means pure substances. Pure substances means made up of only one type of materials. Made up of only one type of materials. So, example I will tell you in the case of hydrogen gas. If you are telling about hydrogen gas, there you can see only hydrogen molecules there, isn't it? Hydrogen molecules you can see only in hydrogen gas, you can see only hydrogen molecule. Can you see oxygen molecule there? No, you cannot see oxygen molecule there, right? So, hydrogen gas. Then if you are talking about oxygen gas, there you can see only oxygen molecules, isn't it? Then if you are talking about water, there you can see only water molecule. And if you are talking about carbon dioxide, there you can see only carbon dioxide molecules, right? So, materials which are made up of only one type of materials, substances which are made up of only one type of materials, then that is known as pure substances. Okay, now we can see the definition of mixtures. Okay, what do you mean by mixture? What do you mean by mixtures? Yes, for that we can take one example. You can make a mixture of sand in water. By mixing sand in or soil in water, you can make a mixture. Okay, so you take one glass of water and take 1 teaspoon of soil. Mix it, you can make the sand in water mixture. Another one can make by mixing 1 glass of water and 2 teaspoon of soil, so that you will get another mixture, isn't it? So all these are sand in water mixture. All these are same mixtures, but their compositions are different, right? So we can say that mixture do not have a fixed composition. Mixture is a substance which do not have a fixed composition. And just now we have seen that a sand and water mixture is made by mixing sand and water. So at least 2 components will be there. So in a mixture there will be 2 or more than 2 components. Okay. In a mixture 2 or more than 2 components will be present there, and those components do not have a fixed composition. Without any fixed composition, if the components are mixing there, then you will get the mixture. Okay. So that is the definition. Mixtures contain 2 or more than 2 components. More than 2 components will be there at a time. 2 or more than 2 components will be there at a time. And the second property or another property we can tell that there is no fixed composition. For the mixtures there is no fixed composition. So such a mixture of material we are calling it as the mixture. Okay. And we have seen the classification of matter into 2 pure substances and mixtures, and then mixtures are again classified into 2, that is homogeneous and heterogeneous. Homogeneous and heterogeneous. So we can say that mixtures are the components. In mixtures are those substances in which 2 or more than 2 components will be present there, and there is no fixed composition. We can make another mixture by mixing salt and water or sugar and water. Okay, any quantities of salt can be dissolved to make in a fixed quantity of water. We can make that salt solution, or a different quantities of water also we can make the salt in water mixture or sugar in water mixture. Okay, and these mixtures are again classified into 2. There are 2 types of mixtures. First one is homogeneous and second one is heterogeneous. Now we can see what do you mean by homogeneous mixtures. Okay, we can see in detail the homogeneous mixtures. So mixtures are classified into homogeneous. What do you mean by homogeneous? Homogeneous mixtures means there is uniform composition between the components. For that we can take one example in case of salt in water. Okay, you are making a salt solution, the mixture of salt in water there, and there once if you are taking 1 glass of water and dissolving 1 teaspoon of sugar in salt in that and making the salt solution there, that mixture you are preparing there, after completely dissolving, can you identify any position or any particular point where more salt is concentrated and less water is concentrated there? No, we cannot, but because salt is equally distributed, evenly distributed, or we can say that it is uniformly distributed in that water. Everywhere the amount of salt mixed with that water is equal. From where all the portions of that solution, if you are taking one by one drop, such as one drop from the top layer, one drop from the middle layer, or one drop from the bottom layer, if you are taking, everywhere you will get the same taste. Okay, so we can say that there is uniform composition. And one more point is that, can you identify their salt layer separately and water layer separately? No, we cannot identify any salt or water layer separately there, because it is uniformly distributed. Once if the complete salt is dissolved in the water, any layer you can, anywhere you cannot identify the salt layer separately. It is evenly distributed. Throughout the solution, that entire salt is distributed. Okay, so we can say that homogeneous mixture means a mixture in which the components have a uniform composition. Uniform composition. Uniform composition between the components. Different components will be there in that mixture, and the different components will have a uniform composition. And one more point, we can say that no distinct boundaries. There is no distinct boundaries. Okay. Example we can say there is, in this case example we can say is salt solution, salt solution, sugar solution. All these are examples of homogeneous mixtures. Okay. Then we can see second mixture, type of mixture, that is heterogeneous mixtures. What do you mean by heterogeneous? Heterogeneous mixtures? Yes, heterogeneous mixtures means just opposite of homogeneous. They do not have a uniform composition. They do not have a uniform composition, and they will have a distinct boundary. For that we can take one example. You take that sand in water, soil in water type of mixture. Okay. Once if you are taking one glass of water, there you can make 1 teaspoon of soil there, and you can make the mixture there. Okay. Then after mixing it, you keep it some time. That mixture you just keep it some time without any disturbance. What you can see there, that soil will be settled down at the bottom and water will be above that layer. That means you can identify the soil layer and you can specifically identify the water level. That means two distinct layers or different distinct boundaries are there for the different components. And there is no uniformly distribution. No uniform distribution is there, because once if you are mixing it, it will be distributed there, but after some time that soil will be settled down there and water we can see above that. And if you are taking one drop of that mixture from the top, there you will get only water. But from the bottom if you are taking, there you will get both water and soil. So the composition will be different for these type of mixtures. Such a mixture is known as heterogeneous mixture. Example, oil. Another example is that oil in water. If you are mixing oil and water, it will remain as mixture, but oil layer will be separated there at the top and water layer will be at the bottom of that mixture. So different layers are separated, the distinct boundaries are there, and they do not have any fixed uniform composition. So these type of mixtures we are calling it as heterogeneous mixtures. Okay. So the points we can see: no uniform composition, and then we can say that distinct boundaries are there. Distinct boundaries are there. Okay. Example, sand and water, oil in water, etc. Okay. So, hope you understood this much. We have seen the classification of matter. Matter is classified into two, pure substances and mixtures. Mixtures means more than two or more than two components will be present at a time, and they do not have a fixed composition there. Okay. And that mixtures are again classified into two, homogeneous and heterogeneous. Homogeneous mixtures, we can say that there is uniform composition and there is no distinct boundaries between the components. Example, salt in water. Heterogeneous mixtures means there is no uniform composition and distinct layers are also present there. Example, sand in water. Okay. And we have seen the classification, the homogeneous mixtures classified into homogeneous and heterogeneous, and this homogeneous mixture is also known as solutions. Homogeneous mixtures are also known as solutions, whereas this heterogeneous are again classified into two, colloids. First one is colloids and the second one is suspension. Okay. Homogeneous is also known as solution, only one category is present. The heterogeneous is divided into two, colloids and suspensions. All these three different types of mixtures, that is solutions, colloids and suspension, we will study in detail in this chapter in further classes. Okay. Hope this much is clear to you. Thank you.